Unit 10 is function operations, and we're talking about 10.1 today, which are sums and differences of functions found on pages 474 to 487 in your text. Our curriculum outcome is 30.6, where we need to demonstrate an understanding of operations on and compositions of functions. And our lesson objectives today: to find the result when two functions are added or subtracted, to be able to sketch the result of the sum or difference of two other functions, and to be able to determine the domain and range of a function that is the result of the sum or difference of two other functions. So remember that we have certain notation that we follow when we are dealing with functions, and functions are written in the form of f of x, g of x, or h of x, where the variable in the parenthesis is a variable that appears in your function. So this unit that we're talking about today is dedicated to exploring what happens when we combine functions in different ways. And today we're specifically talking about adding and subtracting functions. So the way that we write this is h of x, which is going to be our new function, could be f of x plus or minus, because we're talking about adding and subtracting, g of x. So two functions added or subtracted. Or you could have it written like this, where you have the f plus g written as a separate set of brackets, and then the x. These both mean the same thing. So algebraically, when you're adding and subtracting two functions, it's quite easy. You simply add or subtract like terms. Example, consider the functions f of x equals negative 4x minus 3 and g of x equals 2x squared. If we're going to find h of x, which is those two functions added together, that just means you take the two functions and you simply add them together. And we add like terms. Now, in this case, there are no like terms, so we do always arrange it in descending order in terms of degree. So we get 2x squared minus 4x minus 3. Graphically, what you'll need to do is add the y values of each of the functions, f of x and g of x, together at each x value to get your new function, which is we're calling h of x. So consider the functions f of x equals negative 4x minus 3, g of x equaling 2x squared. We're going to sketch the graphs of f of x, g of x, and h of x on the same set of coordinate axes. So here's our graph right here. So to do this, we're just going to create some tables of values. We're going to plug in, we'll plug in 5 points. We'll plug in a point for x, and then we'll get our f of x. And we'll do the same for g of x and h of x. So we'll plug in negative 2, negative 1, 0, and 1, and 2 into all these functions. So for f of x, which we're going to draw in blue, if we plug in a negative 2 into this thing, we get positive 8 minus 3, which is 5. For negative 1, if we plug a negative 1 into our function, we get positive 4 minus 3, which is 1. If we plug in a 0, we get negative 3. If we plug in a positive 1, we get negative 7. If we plug in a positive 2, we get negative 11. So we're going to try and graph this thing. Clearly, my graph won't cover the 2 comma negative 11 part, but we can graph all the other ones. So x equals negative 2 and y equals 5. That's up here. X equals negative 1 and y equals positive 1. 0 comma negative 3. 1 comma negative 7 is somewhere down here. And that is just a line. Try and draw it straight. Obviously, I did not. All right, our next graph we're going to graph is g of x. And g of x, we have our x value and we have our g of x value. We're going to plug in the same numbers, negative 2, negative 1, 0, 1, and 2. So we plug in a negative 2, we get a positive 8. We plug in a negative 1, we get a positive 2. We plug in a 0, we get a 0. If we plug in a 1, we get a 2. And if we plug in a 2, we get an 8. So plugging these values, we've got 8 somewhere up here. Negative 1 comma 2 is right here. 0 comma 0, 1 comma 2, and 2 comma positive 8. So hopefully you've recognized this as a parabola, and sketching it will confirm that. Okay, now h of x, if we're going to graph h of x on the same axis, which we're supposed to, really all you need to do is just add your values together. Now this is probably a bad graph that I have on the slide, but we have a height of negative 2, and we have a height of we have a height of positive 8 and positive 5 here, so the new height would be positive 13. So our green graph would be at a height of positive 13. Here we have a height of 1 and a height of 2. Our new point will be at a height of 3. Here we have a height of 0 and a height of 3. Well, 0 plus 3 is still just, or negative 3, is negative 3. And here we have a negative 7 and a positive 2. which would put us at 5. And then we would just connect the dots in graphing our new graph. Now, the more points you use, the more accurate you're going to be. And knowing what your actual function looks like, we said h of x in the previous slide was f of x plus g of x. So it should be 2x squared minus 4x minus 3. So this new function should be a parabola. So it looks like what we've done here so far is drawn like the left-hand side of the parabola, and soon it would start going up. So we might want to include some other values like positive 2, positive 3, positive 4, positive 5, just to find what that new graph looks like. All right, so we have an example here. It says, consider the functions f of x equals absolute value x and g of x equals x minus 2. We're going to state the domain in the range of h of x equals f minus g of x. So if h of x equals f minus g of x, that just means that it's going to be f of x, which is absolute value x, minus x minus 2. And writing that out, it'll be absolute value of x minus x plus 2. Now, off the top of your head, you don't know what this thing looks like. So we're going to have to graph it. I'm going to graph f of x in blue and g of x in red. So f of x is absolute value x. So if x equals 0, y equals 0. X equals 1, y equals 1. X equals 2, y equals 2. X equals 3, y equals 3. But when I plug in negative values, I get positive y values. So I won't connect the dots because we also saw how that worked last time. It's not very neat. But if you have a ruler, you should be connecting those dots. Our red graph is going to be our g of x. So let's just write f of x in blue. And g of x is going to be in red. And this is our y. This is just a line. So this is our y-intercept at negative 2. And that means that it has a slope of 1. So we'll just be moving up 1 and over 1, up 1 and over 1, etc., etc. So we are going to be taking, for our green function, which is h of x, we have to take our y value for f of x and we subtract the g of x. So we have positive 3 minus a negative 5 makes that positive 8. That puts it somewhere up here. We have a positive 2 and we're subtracting a negative 4. Positive 2 subtract negative 4 is positive 6. 1 subtract a negative 3 is a positive 4. 0 subtract a negative 2 is positive 2. 1 subtract a negative 1 is 2. We've got a 2 subtract 0, which stays as 2. And we have a 3 subtract 1, which stays as 2 as well. So it looks like we get a function that looks something like this. Now, we're asked to find the domain and range. Well, the domain is usually easy to find without a graph. We just look at our two functions and we think, are we restricted by anything that we can plug in for our x value? And in both these functions, we're not. We could plug in any value for x, positive or negative, and we'll get an answer in both these cases. So our domain is going to be XER. It's going to be all the real numbers. Now our range, though, seems to be a little bit different. It seems to look like this function is just going to keep on going up and up and up and up and up, depending on how many points we graph to the left. But everything over here had a difference of 2. So I would say our range is going to be y is greater than or equal to 2. So it'll include everything that's greater than or equal to 2. And I think you'll see in the textbook as well, they'll put in YER probably first. They'll say YER where y is greater than or equal to 2. So now we're going to take a look at the second part of this question where it said, is f minus g of x equal to g minus f of x? And if not, what are the similarities and the differences? So again, our f of x function, is in blue, and our g of x function is in red. And we're going to graph the new h of x function, where in this case, it's going to be h of x is going to be equal to g of x minus f of x. So now we're taking negative 5, and we're subtracting 3. Well, negative 5 subtract 3 is negative 8. We have negative 4 subtract positive 2. Negative 4 subtract positive 2 is negative 6. We have, negative 3 subtract positive 1, which is negative 4. We have negative 2 subtract 0, which is negative 2. We have -1 subtract 1, which is -2. We have 0 subtract 2, which is -2. And we have 1 subtract 3, which is -2. So it looks like it's the exact same function that we had the last time, but it has been flipped in the x-axis. So it looks like it's been a reflection in the x-axis. So the domain actually remains the same, because we can still plug in whatever numbers we want in for our f of x function and our g of x function. So our domain is still xer, but our range is now totally changed. Instead of it being x is greater than +2, it looks like, or sorry, y is greater than +2, it looks like y is going to be less than or equal to -2. And that's for every value of y. So if you're looking for the domain of a combined function and you don't really want to graph it, it's really just the domain that's common between the two individual functions, like the two original functions. So for example, it says to find the domain of h of x if h of x equals f minus g of x, and f of x equals root x minus 3, and g of x equals root 6 minus x. So thinking about our domains for this function, well, this first function, we can never take the square root of a negative number. So it means that every number that we plug into this function will have to be 3 or greater. So the domain here is that x has to be greater than or equal to 3. If we plug in anything less than 3, like a 2, we get a negative number. We can't have that. But we can take the square root of 0, so it can be equal to 3. Over on this other side, we've got g of x equaling 6 minus x. We can't put in a number over here that is greater than 6. If we plug in like a 7, we get a negative number. We can't take the square root of a negative. So we can plug in a 6 or less. So this means that x is going to be less than or equal to 6. So our combined domain for f of x, or h of x, which was f of x minus g of x, our new function will have a range that has to be greater than 3 but less than 6. So our new function's domain, is between 3 and 6. So here's what that would look like graphically. We have our red graph here, which is x minus 3, and the root of x minus 3, You can see that the domain would be everything greater than 3. And we have root 6 minus x, which is everything that's less than 6. And then we have root x minus 3 minus root 6 minus x. Here's what that graph would look like. And you can see that the domain is restricted to numbers between 3 and 6. So in summary, you can add or subtract functions algebraically or graphically. When adding algebraically, make sure you combine like terms, and when adding graphically, make sure to add the y values of both functions together. The domain of a combined function is the common domain of the original two functions, which we just saw, and the range of a combined function is most easily found by examining the graph of the combined function. Your assignment is on pages 483 to 487. Good luck, and we'll see you in class.